Good evening everybody, welcome to my workbench. As you can see, my second radio on the bench. I built that in 2011 and there's a double conversion, and this receiver is actually working very well, except he has a problem with the oscillator, and it seems to be jumping up and down, and for months I've been looking for what would be the trouble. I replaced all the capacitors and so forth. And then I saw one particular video from Carlson on the internet, and he came across a resistor what wasn't functioning very well. So I suspect that I have the same problem, so I will address that. But first of all, I will show you the receiver, how well it really works. You hear the problem? It's only slightly. That was quite loud.
Kann ich verstehen, ja. Das ist ja ganz grob vergleichbar, das ist mein einziger Vergleich. Das ist schon so ein bisschen Speakers und so. Wir haben ja hier natürlich auch mit Low Power gefunkt im Rahmen des Laufen. Und haben dann aber auch feststellen müssen, dass da etliche OMs mit Endstufe funken. Ne? Also einfach so von den Feststellen kann man es abschätzen.
You can hear that the oscillator is moving about, so I'm trying to address this problem, and then the next part of the video I will open them up and show you the part where I suspect that the trouble is. I will remove that particular resistor, and then hopefully we get the problem solved. So when you can hear yourself, this is an excellent radio.
Ja, ich weiß noch warum. Ich sag halt, ich habe nicht gehört. Ich bin ja kurz oben mit EK7 KY und hier 5 KCT, also ich muss den ganz irgendwie schon anpassen. Ne?
The only remark I will make is about this loudspeaker. Now it's not a speaker that you normally use in a tenor or something like that, and well, the tone quality of that speaker is not very good. So this I have to have a look around. Perhaps I can find another one, but has a bit better quality. But anyway, he does the job, and it works very well.
Oh, schönen Abend, ist alles gut.
We can try on the 40 meter band how it goes there. Let's try a bit more signal. Sounds French. I think if there's more low in that speaker, it should sound very nice. But this isn't a speaker, yeah. Well, he's in there, so I have to accept it for the moment. So until I find another one that's the same size, and I'll put that one in. Anyway, as you can see, it is a very nice radio. It's a double conversion. So you have an IF in there from 4.33 megahertz of 4.34 megahertz, and the second IF is 455 kilohertz. So you have a very good stability, except then that the oscillator is playing up a little bit. But apart from that, I had many hours, many hours enjoyment of this radio, and it's actually an inspiration of the normal B40. So in the normal B40, I'll show you another video. I showed you in another video. Is a single conversion, and you can download that schematic on the internet. So if you put in Murphy B40, then you have a very big picture, and you find all the schematics of that particular radio. Anyway, I modified that radio, and let's have a look what I've done, because there's quite some time all again. I have one RF amplifier, I have the mixer and the oscillator. The normal B40 has two RF amplifiers, and it's a bit of overkill, it's my opinion. So I only put one of them in, and well, it was a very nice radio. Well, I put the camera in a bit of a different position, and I'll show you a bit more. Hold on. There you go. As you can see, there are several valves in there. So from pencil here. This is the rectifier. This is the stabilizer. And then you have here the oscillator, the mixer, and the RF amplifier. Then you have the second oscillator here, the second mixer, and then it follows through here, around here, to the end valve. End valve is only a small one, so that's a bit, I think 2.5–3 watts, so it's not that much. So as you can see, this is quite some time ago, and it's a very nice radio. Anyway, you can see here the IF transformer I made myself. It's quite easily to do, you know, if you have the formers and the cores, so it's quite easy to make. Anyway, so here you have the BFO coil and the BFO itself, the valve. So let's see if we can pick more up. Yeah. you can hear, everything is there. So, well, it is a very nice note, as I said before. I keep repeating myself. So, yeah, there you have it. So, I will continue the video later on. It's now evening, and perhaps tomorrow morning I will open up the bottom and I will address this little valve. That's actually the oscillator, and do that. And perhaps I will show you also the schematic I made. This receiver is an absolute success, absolutely. So it's jumping up and down, very annoying. Anyway, I will shut down now, and I will see you tomorrow. For you it will be in a flash, so and I will go through that problem, and hopefully we can solve that problem. Alright, I'll see you later. Good evening everybody. Welcome to my workbench. On the screen you see the schematic of the oscillator of that particular radio, and I want to talk about it a little bit. So yesterday evening I had a check-up on something that caught my attention, and this was the connection on pin 3 of this triode, pin 3, the connection here. There was a soldering point, it was cracked, and after I corrected that, there was some improvement. Well, the radio was good warm, so the oscillator didn't jump anymore, so I think, well, problem solved, very happy. Well, the next day in the morning I switched the radio on again, and there he was again, jumping nicely up and down. After about an hour it all stopped again. Well, it seems to me that the problem isn't solved yet, so we talked about it earlier in the video. So where are we now? Well, in the past I replaced those capacitors here, and that one here, just the two 1000 on well, on the oscillator, on the how you call it, cathode follower, and the connection to the cathode follower. So but unfortunately that wasn't the case, it wasn't the problem. So we still left with the resistors. As I mentioned before with Paul Carlson, he had a malfunctioning resistor in a similar manner. So I suspect this resistor here, R19 220 ohms, that he is perhaps faulty, or perhaps the 47K. So we have to see about that. Anyway, well, I can hear already somebody mentioning, well, the valve could be the problem as well. Well, that's correct, the valve could be the problem, but that also I checked in the past. This valve is in excellent condition, 85%, and there is no short in that valve as well. So the other thing what it could be is the filament and the cathode. That could be a leak there. In the past I had an AC 92 and or 91, what was it? And I had a short in that as well in the cathode and the filament, and that oscillator stopped functioning. So, but as experience grows, as you build, I managed to avoid that. But I put a ferrite bead in the filament, and that stopped all RF or high frequency to ground, so nothing gets past that. So you never get into the position that you have RF or HF built up between cathode and filament. So having said that, we start to investigate further. I will turn the camera off in a minute, and I'll turn them around and open the receiver up, and we have a look inside and see what we can come up with. Alright? Welcome back, guys. Well, let's see if I can perhaps zoom it a little bit. We'll do that. I'll refocus. Okay. You can see here that ferrite bead right there, where I put into for the filament, and that you can avoid all the RF and HF to go to ground, and the valve won't be affected through that. Well, the particular resistor is here at this point. I will remove that resistor, and underneath there is the 47K resistor as well. I see some points I'll have to improve on that. It's about quite some time ago I built this thing, so I see some room for improvement. When I start this off, I will put that right as well. So another poor part I saw here, you probably can't see it. See if I can turn around now. It will be difficult. I can make an attempt. Well, I can't get the camera across there, but there's here a soldering point, I think here somewhere. That looks not very good either, so I will have to go at that as well. And there are some points here, there and here where I have to improve a little bit on, so that can be a bit better than that. Yeah, you can see the past, well, this is quite some time ago, 2011, 10 years ago, so a bit sloppy, I would say, and get that right as well, and then we try and see what the receiver does. It's totally cooled down, or cold. Normally your receivers always the oscillators always have some drift, and that will go away about half an hour or 3/4 of an hour. That will stop. So, but that was not drift, this was jumping up and down from the frequency of the oscillator. So I'll turn the camera down, and I will start off removing this resistor and tidy everything up. I see some things that I don't like, so I'll remove that and make that better, and then we have a go again and see together if the problem is gone, yes or no. I'll see you in a minute. Well guys, I'm back. As you can see, I opened the receiver up again, and I had some investigations done. So as I mentioned before, you can't see it, I did tidy up some parts, and to my astonishing, sorry, I have a good cup of coffee, I discovered I had left some parts from the testing bit in the early stages of building that receiver. Believe it or not, I forgot all about it. So I got them out. I had a little test. Well, believe it or not, he was cold, as it were, and straight away when I switched them on, he started jumping up and down. So anyway, we didn't know that though, so I switched them off again. So I just checked or the receiver was working, that's all. And I have started to remove some parts. I removed the capacitor to the grid, and I removed the resistor where the high voltage is on, so the suspect resistor. And here it comes. You believe it or not, while I was testing this, I went in with this little screwdriver here, this one here, in between the resistor and the capacitor, and straight away he reacted to the frequency he was on. So that tells me a lot. It is quite likely that the resistor is perfectly okay. Yeah, believe it or not. The other point is we need some static screening, because he's feeding back on itself, and the static screening should become between here, just between pin 1 and pin 2. That way. I will solder this on here, that way, and on this pin here, down there, let's take my pencil, down there, I'll solder it on there, and I solder it on there. So we have a sort of screening between pin 1 and pin 2. So we can't feed back on that anymore. So, and it is quite likely that the problem will be gone. Well, I know for sure it will be gone. So the only thing you have to be careful about that we don't make a short here on the bottom. So I think you can see this. Yeah, here this green wire was connected to that resistor. So I will connect that up again that way, back, and put a wire or something else in between. So I just have to see how it goes. I had an RFC in there to stop any RF going into the power supply. How far that it was effective remains to be seen, because if you have the connection here from the resistor and you have an influence, it can be that you have an influence from the coil, or vice versa from the anode, was more likely. So I have to see how this goes, see how effective this we can do. I have my doubts about this capacitor. It's given about 1000 picofarads. It could be, well, you don't want to shut down the oscillator altogether, so if you ground them, as it were, then the oscillating will stop, so we don't want to do that. So there is quite likely there's some residue or RF on this end of this, no, that's not true. I'm saying it's not on the end. It doesn't get through at all, actually. It stays on the resistor itself. So we have to see how it goes. So what I'm going to do next is to cut a piece of this copper sheet and try to put that in there. I will shut the camera down. I do that off camera. I will firstly put another capacitor in there. I did find another one. Probably this one here. You can see it. Nearly. Anyway, you know what I mean. I will put them in there first, and then I'll put the screen in there. So without making a short between pin 2 and pin 1. So I'm going to do that, and I will come back to you. Well, welcome back everybody. So, well, I have a lot to tell you. First of all, I put that resistor in, yeah. And you know, I put the static screening for the oscillator in, so that it doesn't work back on the grid. The other thing what I did is to take the 47K was in this position on ground, took that away and put it on the other side there, so that is out of the way of the anode. Well, again, I was very curious if that cured the problem. Although I was confident that should be the trouble, it worked out it wasn't. It is not the trouble. We went through all of it, all the capacitors they went off, got them out and replaced them or whatever in the past. So the next thing what I did is get this box off and check the connections of the coils to ground and whatever. That was all okay. So, and still I had the problem when jumping up and down. Well, now you're going to ask yourself, is the valve involved? Yes or no? I don't think so. The valve isn't involved. But in all our efforts to get it right, we forgot one very, very important thing. That is the tuning capacitor. Yes, the tuning capacitor. You think, well, that should be alright. No, it isn't. I'll show you. Let's see if I can put it on there. Let's have a look. We can get there. Yes, we do. And there you go. These are the clamps what fitted on the tuning capacitor. And if you look closely, I don't know if you can see it, there is some oxidation going on right there, on there, also on there, on top, and that caught my eye. I thought, well, don't say nothing, and I want to check this out. So I desoldered that from the tuning capacitor, and then I found out the muck what is all around here and there, what is causing the problem. So what I'm going to do next is to clean this all off, make sure that it's contact properly, and then we have a go again when I put that back, and then I'll come back to you and we have fun, I suppose. I think we are solving the problem then. Good morning everybody, I'm back. As you can see, I went a bit further than I actually expected. I was very positive about cleaning that capacitor. So I checked, afterwards I done that, I checked if the problem was gone, and it wasn't. So that left me no other alternative than to get the thing apart, get the coil box out, and I'm going to check that now, see if something is wrong there, and I suspect it will be something wrong there. So I will shut this part down, otherwise that video becomes enormously long, and I will proceed with the investigation. And as soon as I find something, I will put it on the new video and I'll show you where it was. Another thing I was discovering is that signal on the 20 and the 40 meter band was distorted. I have a quite good idea why that happened, so there's probably one on this side of the coil box. Well, probably the problem will be on the coil box itself here on this side, this too. So I think that is quite easily found. Let's turn them over for you so you can see the back. All the relays are involved in there. So anyway, you can see there's a normal board constructed. So anyway, I will shut this thing down now on the camera, and then I will come back to you as soon as I find something to report to you, and then hopefully it will go as planned. As you can notice already, it never goes as planned. So I'm quite confident there's no problem on this on the section of the valves. So we check everything out, every part actually, so even the valve. I have to replace the valve, ECC 82 for an ECC 81, a brand new one, and no problem. Anyway, the problem exists and keeps going, so it is not the valve. So like I said, I'll shut it down and I will come back to you, alright? In the next part. I'll see you then.